So we're starting chapter 4 today, and we're going to talk about what's called radian measure and degree measure. You've talked about before in geometry class where you measured angles of shapes in degrees. So we're going to talk about that and also radian measure, which you may remember from last year. Now, an angle, it's formed by rotating a ray around its endpoint or made up of two rays. And there are two parts of an angle. We have the initial side where the angle starts, and then we have the terminal side where the angle ends. And the angle of rotation goes from the initial to the terminal side. Now, an angle in standard position has the initial side on the positive x-axis. And we can have positive and negative angles. So our grid over here, if this is our initial side, if we were going a positive angle, we go counterclockwise, so we would go this way. So we would say that this is, positive 45 degrees, and we're going counterclockwise. Now a negative angle would go in the other direction. It would go clockwise. And we would say that this is negative 45 degrees because we start from our same initial side, but we're going down. Now you might be looking at this and say, well, what's the difference between going negative 45 degrees down and then going positive 350 degrees, going this way? Well, you are going to end up at the same spot, but your rotation is different. And those are called coterminal angles. It's where they have the same initial side and the same terminal side. So, for example, if we were looking at a 30-degree angle, let's call this 30 degrees. A coterminal angle could be going a full circle and a little bit more, and that would be 390 degrees because we go a full circle and then added the initial amount. So we can adding a full circle. But we could also subtract a full circle. So again, if we start with that 30-degree angle here, and instead of going counterclockwise, if we go this way, clockwise, negative 330 degrees, we subtracted a full circle. That's another way to get the coterminal angles. So for coterminal angles, we are adding or subtracting a full circle. Now, a radian measure, and 1 radian is the measure of a central angle that intercepts an arc equal to the length of the radius of the circle. So for example, if we have the circle here, we have 2 radii here, and a radian would be whatever angle this is right here, theta, for this arc length right here. And let me do that in red. This arc length right here to be the same length as the radius. That's what a radian is. So we can use that to calculate the arc length or radius or the angle measure, the radian, dependent on what information we have. So in this formula right here, we have the angle equals S, which is which stands for the arc length, which was the red part here, over the radius. So if the arc length and the radius are the same, that would be 1 over 1, which would equal 1, and that's the measure of 1 radian. But we could have more than 1 radian. And we can calculate the arc length of a circle if we know the radius. and if we know that angle measure that's given to us. And we're going to do more of that tomorrow, but I just wanted to introduce this as the idea of what a radian measure is. So because the circumference of the circle is 2 pi units, it follows that a central angle of 1 revolution corresponds to an arc of s that is 2 pi r. And then 2 pi is equal to about 6.28. So they're just a little bit over 6 radii lengths in a full circle. So again, like if we look at this picture, this is the radius. There are about a little over 6 of those lengths of segments all the way around. And dependent on where that radian measure is, we know what quadrant we are in as well, based off of this over here that we're going to see frequently. Now, some common angle measures in radians are pi over 6, pi over 4, and pi over 3. And you may remember those from last year. Now, on the next page, we're going to look at the unit circle, which again, you were exposed to last year. And we're just going to fill out the angle measures this time. So we always start at 0 degrees, and then we have 30 degrees, 45 degrees, and 60 degrees. And then this is 90 degrees with the quadrantal angle. So once I get that done, what I like to do is kind of reflect this to some of the other quadrants. Well, you know that a half circle is 180 degrees. And then if we add 90 and 180, down here would be 270 degrees. And then that full circle would be 360. Now I look at the 30-degree angle, and we can reflect over here and say that, okay, this is going to be 30 degrees less than 180 or 150. And if we reflect that down here, that's going to be 30 degrees more than 180, which is 210. And then if we reflect it from here down, it's going to be 30 degrees fewer than 360, so that would be 330 degrees. And then we can do the same with 45. If we do reflect 45 over here, it's going to be 45 degrees fewer than 180, so 135 degrees. And then reflect that down here. And notice that when we reflect them, it lines up perfectly. That's 45 degrees more than 180, so 225. And then over here will be 45 degrees less than 360, or 315 degrees. And then the last one, 60 degrees. Okay, here, let's use a different color. We do 60 degrees less than 180, it's 120. 30 degrees, 60 degrees more than 180, 240. And 60 degrees less than 360 would be 300 degrees. Then we're going to also list our radians. So for our radians, it starts at pi over 6, pi over 4, and pi over 3. And I know that's a little bit confusing because 30 degrees is pi over 6, and 60 degrees is pi over 3. But if you remember that it's the opposite, then that might help. And then 90 degrees is pi over 2. So now what I do here is I do, again, the quadrantal angles. So we had pi over 2. And then adding another pi over 2 would just be 2 pi over 2, or pi. Adding another pi over 2 would be 3 pi over 2. And then a full circle would be 3 pi. Sorry, would be 2 pi. Now with our other measures, okay, so we'll start with the pi over 6. If we reflect it over here, it would be 1 pi over 6 fewer than pi. So 5 pi over 6, because if we had another pi over 6, we get 6 over 6, which is 1. Then here we would go 1 more than that, so 7 pi over 6. Again, if we subtract a pi over 6, we get pi. And then this one would be 11 pi over 6, because if we added 1 more, we would get 360. We would get 2 pi over 6, which is a full 2 pi. So if it helps, we can write that this is 360 degrees and 2 pi right here. Then we go to the pi over 4. Okay, we reflect that over and say, okay, this is going to be 1 fewer than that. So 3 pi over 4, because 1 more pi over 4 would give you 4 over 4. And then this is going to be 5 pi over 4, because that is 1 more than pi. And then over here is going to be 7 pi over 4. 7 pi over 4. And then our last one will be pi over 3. So then this will be 2 pi over 3, because it's 1 less than pi. If we add a pi over 3, we get 3 pi over 3, which is pi. And then if we add another 3 pi over 3, we get 4 pi over 3. And then this one would be 5 pi over 3. So if you look at the numerators and denominators, that helps you to realize where things go. Like over here, all your numerators are 1 less than your denominator. 2 pi over 3, 3 pi over 4, 5 pi over 6. So it's just 1 less than that. Here, all of your numerators are 1 more than the denominator. I don't know what happened here. This should be 3 pi over 2. And then now over here, it is a little bit more confusing because it's not exactly 1 more, exactly 2 more. But what you can think about it is if you multiply your denominator by 2, it's 1 less than that. 6 times 2 is 12, minus 1 is 11. 2 times 4 is 8, minus 1 is 7. 3 times 2 is 6, minus 1 is 5. So these are angles that you're going to have to know for our stuff going forward. So now we're going to sketch an angle in standard position. When we sketch an angle in standard position, what we're going to do is have our axes. 11 pi over 6, it's almost 2 pi, right? 11 pi over 6 is right here. So we have our initial side is going to go almost a full circle in this direction. And you want to draw the arrow so we know what direction we are rotating. So that would be 11 pi over 6. And negative 210 degrees, well, remember, negative angles go clockwise. So it's going to go this way, but it's going to go a little bit more than 180. And that would be negative 210 degrees. Example 2, we're going to find 2 coterminals, 1 positive and 1 negative. So to find coterminal angles, we're going to add or subtract a circle, which is 360 degrees or 2 pi. So we're going to have to figure out which one to use. If we have pi in our original, we're going to add or subtract 2 pi. So we have 11 pi over 6. So we're going to add or subtract 2 pi. Well, those do not have the same denominator, so it's really going to be 12 pi over 6. So for the positive one, we're going to do 11 pi over 6 plus 12 pi over 6, which is equal to 23 pi over 6. And then for the negative coterminal angle, we're going to subtract 12 pi over 6, and that's going to give us negative pi over 6. So these two angles have the same terminal and initial side as 11 pi over 6. Then letter B, we have negative 13 pi over 4. So we are going to have to add or subtract 2 pi, which is really 8 pi over 4. So then we'll start negative 13 pi over 4 plus 8 pi over 4. That gives us negative 9 pi over 4. So by adding a circle, we still got a negative coterminal angle. So I don't want to now subtract 2 pi, because that's just going to get more negative. So let's take that new negative angle that we got, because that was our one negative one we're supposed to calculate, and add another 8 pi over 4, which is 2 pi, and we get 3 pi over 4. Then we have 150 degrees, so now we're going to plus or minus 360 degrees. So 155 plus 360, that is 515 degrees. And then 155 minus 360 degrees, that will give us negative 205 degrees. So the idea with coterminal angles is we want to add or subtract a full revolution or a full circle, 360 degrees or 2 pi. So now we're going to figure out how we can convert from angle measures in degrees to radians and vice versa. Because if you've forgotten that, 315 degrees is 7 pi over 4, but if you know the conversion, you can still go forward with the problem. So from degrees to radians, we would use this formula. So we would do 315 times pi over 180. So this would equal 315 pi over 180, which would then simplify to 7 pi over 4 once we reduce that fraction. Now going in the other direction, we would multiply by the same conversion factor but flipped. So 180 over pi. 180 over pi. So we would have 180 times pi over 9 pi. The pi's would cancel, and then 180 divided by 9 is 20 degrees. So the main idea from this is to just understand the idea of angles in radian measure and how they're interchangeable with each other. All right, so thanks for watching the video. Make sure to like it and subscribe.